everyone, this is a lecture on 2.1, okay? So this is about solving, okay, systems of equations, okay? So this is actually really, I guess what I should say, right? This is really an overview on all of chapter 2, okay? So 2.1 has a solving systems of equations by graphing. Okay, so when we solve systems of equations by graphing, there are three possible outcomes. Okay, one possibility is that there is exactly, one solution to our problem. Okay, so if I have exactly one solution, what that looks like is that, let's say I have one line, right? Let's say I have the equation y equals x, okay? And then I have another line. What should it be? Let's see. How about it's this line right here, okay? So the equation of this line is y is equal to negative x plus 2, okay? And you can see that these two equations, right, these two lines intersect at that blue dot right there. And you can also see, hopefully, from my little thumbnail sketch, that the coordinates of that point is 1, 1. Okay, so that is the solution to the system of equations, okay? So we're not always going to have exactly one solution, okay? Sometimes there is no solution at all, okay? So what that looks like, again, I'll sketch you guys a little graph here, okay? So let's say that we have the line y equals x, okay? And then let's say I have also this other line right here, okay? So that is y equals x plus 1, okay? And this is y is equal to x, okay? And if you remember from previous days, these are what are called parallel lines, okay? So parallel lines never intersect with each other, or mathematicians, just to be fancy, sometimes they will say that they intersect at infinity, which is exactly precisely the same as saying that they never meet, right? It's just a fancier way of expressing the same thought or idea. Okay, so, right, so one possibility, like I said, is that these lines intersect at exactly one point. Another possibility is that there is no solution, okay? A third possibility, okay, and this is not going to make super much sense when we look at it graphically. It'll make a lot more sense when we start exploring the algebraic aspect of these problems, is that there are an infinite number of solutions, okay? And what happens is that we're given what appear to be two different equations, okay? But, maybe they're just sort of rearranged. They're not both expressed in slope-intercept form, right? But then we go to graph them, and we find out that these two supposedly different equations, right, linear equations, okay, are actually the same equation. Okay, so again, it looks like we were given two different equations to graph, but oh no, we find out that there's actually only one line, okay? So again, in 2.1, that's what we'll be doing. We'll be finding that there's exactly one solution, like this point right here. Oops. Right, we'll be finding out that they are parallel lines, so they never meet or they meet at infinity. Or we might find out that even though it looks like we're given two different equations, when we graph them or algebraically rearrange them, they end up being the exact same equation. Okay, so in 2.2 and 2.3, okay, we are literally doing the same thing. Okay, we're just not using graphing anymore. Let me do this. Okay, we're just using algebra. Okay, so 2.2 is, if I remember correctly, substitution. Okay, where we take one equation and we put it into the other equation. Okay, and I think the book calls it addition is what the book refers to it. I don't really particularly care for the term addition because guess what, y'all? You can also subtract it, and sometimes also you have to multiply by a constant. So I think that the term, which honestly most math books use, is elimination. Okay, but just know if you see the term addition, solving by addition, solving by elimination, they're the same thing. Okay, so if we wanted to, let's say here, right? So let's say we're given the equation y equals x, okay? And then we're also given the equation y equals negative x plus 2, okay? What substitution has us doing is taking the y equals x. So that means anywhere I see y in this second equation, I am going to substitute the x into that equation. So this y equals negative x plus 2, okay, it becomes x equals negative x plus 2, okay, and then now we only have the one variable, which is excellent, right? That's what we want. So we add x to both sides, and we divide by 2, and we find out that x equals 1, okay? Now, as you can see here, right, there are actually two solutions, right? We need to find not just our x value, right, but we also need to solve for our y value as well, okay? So then, algebraically, I would go back, right, and I would take this x equals 1, and I would plug it into either of these equations. So I'll put it in here, right? So then I find out that if y equals x and x equals 1, then y is also equal to 1. Okay. So, algebraically, if I have no solutions, what's that going to look like? Okay. So, let me just demonstrate for you guys here what it's going to look like if I try to solve an equation, okay? Again, I'll use substitution. You could use elimination, doesn't matter. Okay, so if I take this x again, I'm substituting it into my second equation, okay? And so this becomes x equals x plus 1, okay? So again, attempting to solve this, x minus x is 0, so 0 equals 1, okay? Hopefully we all feel comfortable saying that this is not a true statement, this is false, okay? So anytime you're using either substitution or elimination and you get something that looks like 0 equals 1, right, or 2 equals 5, right, a statement that is mathematically false, okay, that means that there is no solution, okay? And again, if you went back to the graphical method, which is right here, you would realize that the reason there's no solution is that the lines are parallel, which again means that they have no point of intersection. Okay? All right. So the last one, okay, I'm going to erase this simply because, as you can see on my screen, I have like no room. Okay? So this is the line. The one I graphed is the equation y equals x. So let's say that one of the equations I was given is y equals x. Okay? And then the other equation that I was given, let's say, was 2x minus 2y equals 0. Okay, so again, I'm going to use substitution. You could use elimination, does not matter. Okay, so wherever I see the y in the second equation, I'm going to use substitution and put this x in there. Okay, so this becomes 2x minus 2x equals 0, which is the statement 0 equals 0. Now, I don't know about you guys, but I kind of already knew that 0 was equal to 0 before I started this process, right? So if 0 equals 1, right over here is a mathematically false statement, right, then 0 equals 0 is a mathematically true statement, right? Again, it doesn't really help us or give us more information, right? But it is always true, regardless of the values I choose to assign to x or y, okay? So, because of that, we say that there are infinite solutions, okay? So hopefully this video, my goal here, was to help you to understand that if you are able to obtain a single value for both x and y, algebraically, right, then that means graphically your solution has two non-parallel lines which intersect at a single point. Okay? Algebraically, if you go through this process and you end up with something that is not true, like 0 equals 1, right, that means you're working with parallel lines, and that means that your system of equations has no solution. Okay? And lastly, if you end up with a mathematically true statement, right, like 0 equals 0 or 5 equals 5, anything that you kind of already knew, right, then that means that even though it looks like you have two different equations, you were in fact only given one equation, right? So the line is literally like superimposed on itself, right? It has all points in common with itself, and so therefore your supposed system of equations is actually only one line, and therefore there are an infinite number of solutions that satisfy that system of equations.